We know that we already studied what is acceleration due to gravity and what are the factors affecting the acceleration due to gravity. So acceleration due to gravity, if you have taken, will represent with a letter called as, what is the symbol of acceleration due to gravity? Harish, is G. Yeah, small g. So we're having three factors which is affecting it. Anybody can tell me what are the three factors? Mr. Johan, Mr. Gokul. One is what? One is altitude. Next one is what?
Depth and latitude.
Next one is what? Latitude. Okay, that is what it is we have been studied. Yes, Harish Zeras, have you attended this latitude and you learned this or not? I told you to solve the numerical of acceleration due to gravity of moon. Yes?
Yes, sir, I solved it, sir.
Yeah, very good. How much you got? 1 point? Acceleration due to gravity of moon.
I don't know, sir. I will check it.
Just 1.63. You should learn that value also. Value also important. Harish, call to Kaushikra. Okay. Now, as I told you, if we'll consider, if this is the Earth, for example, if we'll consider not only Earth, any kind of planet, observe very carefully. If I consider this is the any kind of planet, then all the planets where the acceleration gravity is maximum, only at the surface. Where it is having maximum acceleration due to gravity, everybody? At the surface, understanding? So any kind of planet, of course we know that different planets is having different acceleration due to gravity, but at the surface only it is having maximum g. All of you should remember. Now when I keep on going away from it, that is what? Altitude. So that g value decreases or increases, everybody? Yes, please. G value decreases. Okay, all of you, that is what you have to remember. Same way, when I keep on going inside depth, if I am keep on going, this is altitude. Same way, this is depth. Understanding? Now, this is also G value decreases or increases? G value will be decreases. Now, at the center of any kind of planet, if I reaches to the center, then always G value become what, guys?
0.
Yes, Johan. 0 meter per second square. Yes, Johan, yes or no? Harini? That is what? What is your? That is what. So, next, if we take, as I told you, our Earth only. Earth is not a complete spherical. It is having little, what is the shape of the Earth? Anybody?
Ellipsoidal.
Ellipsoidal shape. What is the shape of the Earth? Ellipsoidal shape. Understanding? Ellipsoidal shape. So it is having from the center, it will take where it is having larger radius. Everybody, it is having larger radius at where? At equator. Understanding? And at the poles, it is having flattened surface. It is not completely spherical. At the poles, it is having flat surface. So poles it is, North Pole and South Pole. So radius at poles. So which is greater? Radius at poles or radius at equator? Everybody?
Radius at equator.
Radius of equator
is greater than radius at poles. So if radius is increasing, gravitational force will decrease or increases? Yes or no? Gravitational force will decreases. So radius at equator is greater, but radius at gravitational force at equator is less than gravitational force at where? Gravitational force at poles. So that is what you should understand. Yes or no? Till here we studied in the last class. Yes, Mitakshri? Harizeras? Johan?
Sir.
Yes. So remember,
Yes,
that is what we can say factor called as latitudes. Understanding? So radius at equator is larger, greater. So when we are moving towards to the equator, so our gravitational force decreases or increases? Towards to the equator, gravitational force will
Decreases.
Decreases. Also remember, when we are moving towards the equator, gravitational force will decreases. When we are moving towards the poles, gravitational force will
In
increases. Understanding? That is what. But we know what is our Earth gravitational force, acceleration due to gravity, average acceleration due to gravity of Earth. Everybody. Yes, please.
9.8, sir.
9.8.
To mass of Earth divided by average radius of Earth whole square. If we'll do this one, we'll get the value. How much it is? 9.8 meter per second square. Next, if we'll take moon, can you tell me, Mr. Johan, Mr. Kaushik, what is the moon will come? Moon. Acceleration, this is what? Universal gravitational constant into mass of moon divided by what, guys? Radius of moon whole square. What is the value, Mitakshri? Harini, open your mouth, Harini. Gokul, 1.63 meter per second square. Is it yes or no? Everybody?
Yes, sir.
Must know these values. Please kindly remember, gravitational force of Earth, gravitational force of moon. We must know this. Okay. So what is the gravitational force of Earth? 9.8 meter per second square, and the gravitational force of moon is 1.63. How much it is? 1.63. Learn that values. Now, all of you observe very carefully. Can you find the relationship between gravitational force of Earth and gravitational force of moon? Mr. Hari Zeras, Divya, how are you, Divya? Fine. After so many days. Can you hear me? So can you tell me, Mitakshri, Harish, Harizeras, anybody? What is the relation? You might be noticing. Gravitational force of Earth is sometimes like some number of times is more than gravitational force of moon. Can you find it? How many times it is? Yes, Mitakshri? Just to see that, I will say, is it right or wrong? You tell me. I will say that gravitational force of Earth is 6 times of gravitational force of moon. Will you accept it or not? All of you try. Is it right or wrong? You tell me. So what is the gravitational force of Earth, Mr. Johan? You should tell me answer. What is the gravitational force of Earth?
Sir, small g is equal to capital G.
Gravitational force of Earth value. Of course, formula you leave it. Formula is capital G into capital M divided by R square. Forget about it. I'm asking value. What is the gravitational force of value? Acceleration due to gravity of Earth. I'm asking. Acceleration due to gravity of Earth. Value.
9.8.
Very good. 9.8 meter per second square, which is equals to 6 into. What is the acceleration due to gravity of moon? Divya, here only there. Harijeras, you solve that question. You told you solve that, but you have to solve that question. Okay. Yeah. What is the gravitational for acceleration due to gravity of moon? Everybody. 1.63 per second square. Now do the multiplication, all of you. 1.63 into 6, Mr. Akilan. Gokul Krishna, no response at all. Tell us. Yes, how much it is coming?
9.78.
9 point, all of you. 9.78. 9.78, Hari, not 9.8. Just check it. Is it right or wrong?
9.78, sir. Yes, sir.
9.78 meter per second square, approximately equals to, I can take second digit as 1 plus 1, I can remove it, 9.8 meter per second square, which is equals to 9.8 meter per second square. Right or wrong? Everybody? Yes, Hari? Yes. Because why I am saying this means, before going to study mass and weight, you need to know this one. That is why. So, can I say, acceleration due to gravity of Earth, acceleration due to gravity of Earth is 6 times greater than whom? 6 times greater than whom? Mitakshri? 6 times greater than acceleration due to whom, guys?
Moon.
Gravity of moon. That's all. Understand, everybody? Yes, please.
Yes, sir.
Yeah. Now, can you tell me the reverse relation? Hari, have you called to Kaushik?
Yes, sir, but he did not attend, sir.
That's fine. Okay. Can you tell me now? Reverse relation. Anybody? Let me see who will say. What is the gravitational acceleration due to gravity of moon? Moon is how many times? How many times it is in the earth? Anybody? I am saying that gravitational acceleration due to gravity of earth is six times greater than moon. Understanding? Now I want acceleration due to gravity of moon. Anybody can tell me what is the will come?
Yeah, 1, sir.
Yes, 1 by 6 into acceleration due to gravity of earth, which is equals to acceleration due to gravity of earth divided by 6. Is it right or wrong? Will you accept it, all of you?
Yes,
Yes,
sir.
all of you. No. Johan, Harini, Arun Kailash.
Yes, sir.
That's all. So if you want, you can do the division, you'll get the answer. So that is the relation. Please not learn it. So 9.8 divided by 6 if you'll do. So how much will come? 9.8 divided by 6 if you'll do, you'll get equals to 1.63 meter per second square. So means it is a gravitational acceleration due to gravity of moon. Is it right or wrong? Yes, everybody?
Yes.
That's all. Okay. So this is what the relationship between acceleration due to gravity of Earth and acceleration due to gravity of Moon. Please learn it. If you learn this one only, then next concept is very easy for us. Yes, Mr. Hariseras, understand Gopal Krishna, Divya?
Yes, sir.
Read out, please ask me. You should learn day by day. That is what I want. Next. If it is once over, then tell me, I will say next concept. We'll move to the next concept. Clear, guys? Everybody? Clear?
Yes, sir.
Yes, sir.
Yeah. Now, so is it completed, everybody? Have you done this all the things? Okay. Now keep heading. Keep heading. The next concept which we are going to study, as I told you, is called as free fall. After free fall only, we will go to mass and weight. Okay. So all of you keep heading free fall. Free fall. Okay, guys. Now, let us observe very carefully, guys. Now, if you want to understand the free fall, then you need to know something called as acceleration due to gravity. That is what I am saying you here. So, shall we start now? Everybody, are you ready? Free fall.
Yes,
Yes, sir.
So let us understand what do you mean by free fall. Means in the sense of, now, let me take now for example, this is what your house. All of you observe very carefully. This is what your house. Okay, everybody, guys? House. Now, you are standing on the terrace. You are standing on the terrace. Now, imagine you people will drop 1 kg stone and another one is 5 kg stone. How many stones? 1 kg stone and 5 kg stone. Now, you tell me which stone will reach the ground first. My answer. Everybody should answer. Mr. Johan and Harini, you also open your mouth. Then only you will improve. I am dropping 5 kg stone and 1 kg stone. Can you tell me which one will reach the ground first and which one will reach the ground next?
sir. 5 kg, sir. We will reach the ground first.
All of you should answer. What is your opinion? Yes, Divya, I'm asking you. Keep on, but no response from you. I want to know which one will reach first and which one will reach next. Mr. Hariseras, Arun Kailash, I'll start with Arun Kailash. What is your opinion, Mr. Arun Kailash? Yes, please. No opinion? Yeah, Johan, what is your opinion? Harish is saying that 5 kg will fall first and 1 kg will come next. Hari, why are you saying 5 kg will fall first, Hari?
Because its mass is high, sir.
Oh, its mass is high. Very good. Okay. So Hari's opinion is 5 kg will fall down because its mass is more. So mass is more, so that you can say a very good Hari. Yes. Can any other? Yes, please.
Sir,
Mithakshi?
both will fall at the same time, sir.
At the same time? Why? How you can say both at the same time?
Because they are at the same place, sir, and the gravitation will be the same for both, sir.
That is what we are going to study in our today's class. Very good, Harish. Now remember, of course, we can see that in lower classes and all, they'll say that, for example, I will drop a rat and I will drop an elephant. Understanding? So, elephant will fall first and rat will fall next, they'll say. Because, as we know, Newton's second law. Can you tell me Newton's second law, Mr. Gokul Krishna? Force F is equals to what is that? Mass into acceleration. From that, can you tell me the acceleration? Acceleration A is equals to, what is the formula? A is equals to, Johan, A is equals to force by mass. Yes or no? So what is the relationship between mass and acceleration? Acceleration is inversely proportional to, yes please, acceleration is inversely proportional to mass. But you tell me here, you can see elephant is heavy mass, but still it is falling fastly. But here see what, mass is greater, acceleration is less, but still due to heavy mass, so that the pulling force will be more, so that we can say it will fall first, and the rat is having less weight, so that it will come later. This is what we'll study basically, but it is entirely wrong. As Hari said, what is our free fall means, in the sense of, observe very carefully. If any kind of object is falling towards to the ground, Hari says, no external force,
Yes,
no external force is acted. No external force means, what is the force? Anybody can tell me, Mitakshri? No external force is acted means, in the sense of what? Like air. Understanding? Air friction or some other kind of friction forces and all should not act. It must be what? No external force is acted. Then any kind of object, the acceleration due to gravity acting on it is independent of mass. So mass is not at all a parameter. So all the objects will reach the ground at the same time. That is only called as free fall. Understand, Hari? Understand, Divya? Are you clear, Akilan? Remember, if any kind of object, for example, all of you open a Chand book, you are having a Chand book, Harish, you are also having a Chand book. Yes?
yes, sir.
Yeah. You'll be having one experiment called as Galileo experiment. Can you tell me the page number? What is it experiment? Harish? I'm not able to open. Can you tell me that? All of you. Yeah, Galileo experiment. One Galileo experiment will be there. See, Metakshri? Yeah, okay. If it is not there also, of course, here for me book is not opening. Let it be. Now, observe very carefully. Now, I have given you one feather. You all people know feather means. Yes or no? Feather means you all people knows, correct? Any bird feather. Okay. Now, I have taken one hammer. Now, you tell me both I will drop. Then who will reach the ground first? Yes, Mr. Johan? At normal air, if I drop it, then who will reach the first? Everybody?
Sir, hammer.
Hammer. Very good. Hammer will reach first compared to feather. Why? Feather is very, very less mass, so that it will fly due to the frictional force of whom? Due to the frictional force of whom, guys?
Air.
So that air is trying to fly away, air is pushing, so that feather will take more time to reach the ground compared to the hammer. As it is, hammer is more mass, so air cannot resist it, so hammer will fall fastly. Yes or no? Everybody? Yes?
Yes.
Now, both the same feather and hammer, if I have been dropped in the vacuum, if I have been dropped in the vacuum in the sense of what? No air is present. No air is present means in the sense of no external force is acting. Then remember, if I will drop the feather now, if I'll drop the feather now, and as well as if I'll drop the hammer, are you understanding, Hari? Divya? Then both will reach at the same time. Both will reach the ground at the same time. When guys? No external force is acting. No air is present. Understanding? No external force is present. So external force is acting. So only here one force is acting. What is that force? Anybody can tell me? What is the one and only force is acting? What is the only one and only force is acting? No external force is acting, but one force is acting. Only one force. What is that force?
So
Gravitational force.
Acceleration due to gravity. That is what? Due to gravity. We can say that is only called as gravitational force. So the one and only force is acting is gravitational force. Then keep it in mind, all of you, Mr. Galileo, when he has been dropped the two stones from the a big tower. What is that big tower called as? Anybody can tell me, Hari, what is that name called as? That bended building. It is there in our book. See that, everybody. What is that? Hari, gravitation chapter, it will be there. Just see. For me, it is not opening. That is why. Pisa Tower. Do you remember that Pisa Tower? Mr. Hari Zairas, do you know that one is, it is little inclined? One of the wonder. One
Yes,
of
sir.
yes,
yeah, what is the name of the tower?
leaning tower, sir.
Pisa Tower.
Hari?
Leaning Tower
Sir.
of Pisa.
Leaning Tower of Pisa. Understanding? So Leaning Tower of Pisa. When Galileo dropped two stones from that building, he has noticed that same mass or different mass. Can you tell me? He has been taken what? Different mass.
Different mass.
So when he dropped two stones above from that building, which is having different mass, he noticed it. Independent of mass, independent of their masses, they both reached the ground at the same time. Understanding? So that point only, same time only they reached the ground. From that point only, they have been defined a definition called as free fall. Free fall in the sense of no other external force is acting. If a body is falling towards to the ground only due to the one force. What is that force, guys? What is that force? Akilan? What is that force? Gravitational force. Then independent of mass, all the bodies will reach the ground at the same time. That is only called as free fall. So a body which is having more mass, a body which is having less mass, doesn't matter. When they are only of the influence of acceleration due to gravity, then independent of their masses, they will fall at the same time. That is only called as free fall. Understand, Mr. Hari Zairas? Only which force will act, Hari?
Yes, sir.
Only gravitational force. We have to neglect all other forces, means like air resistance and all. Then we can say it is free fall. Now, I will say you all the things, try to store in our mind because writing is very, very difficult. Everybody listen very carefully. Now, you all people know, how many of you know pulling water from the well? I think Kumbakonam more wells are there still. They will get the water from wells only, temples and all. Yes, Mitakshri, do you all people know? At least say yes or no. You all people know or don't know? All of you?
Yes, sir.
Yeah.
Yes,
So
sir.
that a bucket tied to a rope which is passing over a pulley falling in a well. You all people knows that, correct? Just we are having a well. So now you might be notice it. This is what my well you can take. So now I'm having a pulley here. This is what my pulley. Now the rope which is attached to a bucket is attached. So now you tell me if I'll release this bucket, now bucket will go and will fall down directly into the well. Now, what kind of force is acting on it? Anybody can tell me? What is the force acting on it? Yes, please speak, everybody.
Gravitational force.
Yes, Hari. What is the forces acting on it? Try to answer. Some people are making noise. Some people are getting noise. Johan, I think. What is the forces acting on it? I'm dropping a bucket which is tied to a rope over a pulley. Over a pulley. Now you tell me what is the forces are acting on it. Yes, Harish, Mitakshri, Akilan.
Sir, gravitational force.
Yes, please. What is the force acting? All of you. Force acting on it are what? Gravity. First force is what? All of you should say. What is the force acting? Gravity is acting. Very good. Next one. Some force is acting. It is attached to the rope. So that rope friction is also acting or not? Everybody? The friction rope is acting or not? Friction between the rope and pulley, which is oppose the fall of the bucket. Understanding? Frictional force between the friction between pulley and rope, which will what? Will oppose the fall of the bucket. Yes or no? Yes,
Yes,
Mitakshi?
sir.
Fall of the bucket. But still bucket will fall down. Why it will fall down? Still bucket will fall down. Why? That is what my question. All of you. Because acceleration due to gravity is what? More. Do you understanding? So that is what will happen. Are you clear, everybody? Same way, if we'll take you can take Ponai Selvan or PS1 or Bahubali, you're having a big mountains. You might be see, that is what we can say. Big mountains we used to call with some name. Can you tell me anybody? What is that large big stones we used to call it as? Cliff. Cliff we can say. Now, let me imagine Mr. Gopal Krishna is standing here and he dropped a stone. What he dropped? What he dropped? He dropped a stone from a cliff. Now you tell me, in addition to the gravity, one more force is acting on it. Can you tell me what is the force? He dropped a stone along with the gravitational force. Of course, gravity is acting, but along with that, one more force is acting on the stone. Can you tell me what is that? Yes,
Sir,
sorry.
frictional force.
Yeah, what?
Air resistance.
What is the frictional force acting? Mitakshri, on the way. Yes.
Air resistance, sir.
Resistance. Yes, please. So another force which is acting is air resistance. So observe here. So whenever you can take, not all the bodies fall down freely. You might be notice it. Whatever the body will fall down doesn't mean that it is falling freely. A body is said to be falling freely only under the influence of what force? Mr. Hari Jairas, Arun Kailash? What is the force which must be? It must be under the influence of only one force. What is that force, guys?
Gravitational force.
Gravitational force. Then we can say it is free fall. All of you should remember, no other force acting on it. Only a body should fall down when it is under the influence of what force? Gravitational force or gravity alone. Then it is called as free fall. Understand? So that is why Mr. Galileo conducted experiment. He tried to drop the feather and as well as hammer in normal air, so that hammer only reaching the first, but feather is not reaching the first. Why the feather is not reaching? Because of what resistance? Air resistance. So feather is taking more time to fall down. Now, if I restrict it, no other external force is acting. Means in the sense of in vacuum, if I drop feather and as well as hammer, then I notice it, no other external force, no other forces are acting. Then I notice it, both feather and hammer is reaching the ground at the what time? At the what time, guys? At the same time. Understanding means in the sense of at this case only one force is acting. What is that force? Acceleration due to gravity. Then these bodies are said to be in what? These bodies are said to be in what?
Free fall.
Free fall. Understand, Mr. Haris Eras? So if any body
Yes, sir.
be in free fall means in the sense of what? Everybody, it is only under the influence of what? It is only under the influence of everybody.
Gravity.
Gravitational force. That is what. Then all the bodies will reach us the ground at the same time. No slow down, no fast. All the bodies, the acceleration due to gravity is exerting same. Then both will reach us at the same point, independent of their masses. Mass is not at all a parameter. So that is called as free fall. I hope everybody understand what is free fall. Yes, are you clear? Midakshri, Divya?
Yes, sir.
So free fall means immediately one word should come into mind. What is that word? Only one
Gravitational.
is acting. What is that force? Harini? Gravity. Understanding? So you can take everything. Only one force is acting. That force is called as gravity. And the second word, what is the second important word? Harijairas, Akilan. Second important word. Independent of their masses. What is the second important word? Independent of their masses. Okay, so please write it. A body is said to be falling freely. A body is said to be falling freely. Free fall. A body is said to be. Johan, understand, Johan? Gokul?
Yes, sir.
Yeah, right. A body is said to be free fall. A body is said to be falling freely. Please write it. A body is said to be falling freely. A body is said to be falling freely, or in a state of free fall, or in a state of free fall, when it is under the influence of, when it is under the influence of what force, Divya? Open your mouth. Under the influence of what force? Under the influence of everybody. Under the influence of what, guys? Gravity.
Only gravity.
Yeah, gravity alone. Gravity alone. And no other forces act on it. And no other forces act on it. That is what? Free fall. Okay, second point. And also what? This gravity is dependent or independent of masses, guys? Dependent or independent of masses?
Independent, sir.
Independent.
Independent of masses. That is the second point. Right. When bodies are in free fall, when a bodies are in free fall, please write it. When a bodies are in free fall, when a bodies are in free fall, when a bodies are in free fall, comma, the acceleration due to gravity, the acceleration due to gravity acting on them is the Harijairas, clear? Gokul? Acting on them.
Yes, sir.
Yeah, acting on them is the same acting on them is the same, and it is independent of what? And is independent of what, guys?
Masses.
Of their masses. So that is what. So if I'll take a feather, and if I'll take a hammer, so if they are falling only under the influence of gravity, then what is the gravity acting on the feather and acting on the hammer? Both, what is the gravity acting? Earth, which is equals how much? 9.8 meter per second square. Here also how much? 9.8 meter per second square. No other forces is acting. No other forces act